Dr. H.A.C.K. Kundu. Dr. Ashish is a distinguished scientist, leader in the area of security, privacy, compliance, and many, many other things. So he has led security compliance of self-driving cars, UAVs across all the various stacks. He has led security compliance for cloud-based healthcare, cloud-based AI-driven platforms. He has led cybersecurity of
Just to inform, we are not able to see your screen, okay?
Yeah, I stopped sharing for a second. I will restart in a minute. So Dr. Kundu has received his PhD in cybersecurity from Purdue University. And for a long time, he was a senior research staff member at IBM T.J. Watson in the US. He was a master inventor. He has more than 150 patents filed, with more than 110 of them granted. He has 40 plus research papers, and he has been, multiple numerous awards, ACM Distinguished Speaker. He's a distinguished member of that. He has got awards from Purdue University for his dissertation work. So he is a long track record of working in cybersecurity for the last 15, 20 years. And he is specifically and specially focused on using AI and ML, machine learning, artificial intelligence for cybersecurity in a variety of roles, right? A variety of aspects, looking at the technology aspects, ethics, compliance, the false positive concerns. So we thought it'll be very appropriate to address that topic, because every cybersecurity today, uses AI and ML in some form, right? Hopefully in the products, but definitely in their pitch decks where they talk about using AI and ML. So this Ashish is going to go into various aspects. I mean, he has he can talk for like 10 hours on this topic, but hopefully we should be able to get started with this session and cover as much as we can today. All right. Thank you a lot, Ashish, for joining. And Ashish is joining today from Orissa. He's visiting India from the US, and he's having a bit of connectivity issues. So hopefully that should not get in the way of today's talk. With that, let's get started. Again, as always, this is going to be an open format. So if you have questions that are relevant, that cannot wait till the end, please do feel free. This is again a 2-hour session. We hope to have about 1.5 hours of. Ashish has put together a lot of his a lot of fantastic material in this presentation. But towards the end, there'll be a lot of opportunity for people to clarify any aspects of AI and ML with the expert. So thanks again, Ashish, for joining, and please get started. And like always, we'll be recording this meeting. Abbas, have you already started this recording?
It's already started.
Okay, great. All right, Ashish, take it away. Give me 1 second. I'll start sharing your slides, and just call out the slide numbers, and I will flip the slides for you. Abbas, can you please approve? Okay. All right. Can everyone see the slides that I'm presenting?
No, we cannot see it.
Okay, give it a second. It might be coming up. No, nothing yet.
Yes, we don't see anything yet.
Okay. Let me try again.
It's showing 2 screens. One is from Koti Reddy, another one is from Ashish Kundu. Yeah, now it is one.
Okay. Ashish, can you, are you sharing as well?
No. I'm not sharing, Rajiv.
Oh.
But now the screen which is active is from the Ashish Kundu.
I see. Okay. Yeah, I think all of us are trying to figure out all these various platforms. So give me 1 second. Is it sharing now? Can you see the slides?
Yes.
Yeah.
Okay. All right. Good. Take it away, Ashish. Thank you.
Okay. Thank you so much, Rajiv, for the generous introduction and thank you so much, everyone, Karthik, Abbas, and everybody else, especially the entrepreneurs, the founders, and the key members of the startup community. Um, I appreciate your time. I hope it's going to be useful, right? Now, the topic of today's discussion will be leveraging AI and ML by cybersecurity startups and the related challenges, right? Especially we'll focus on the challenges and why we think that we should be careful in the way we look at building a business out of AI and ML for cybersecurity, okay? And what things we should take care of carefully, right? Next slide, please. So if you look at the today's startup ecosystem, right? This is just one glimpse by CB Insights, actually. So the source of this is mentioned at the bottom of the slide, right? Now there are 80 companies, let's say, or in fact there are more than 80 companies who are looking at how to apply AI for cybersecurity, right? Now, if you look at the title of it, right, 80 plus companies securing the future with artificial intelligence, right? That's that looks to be quite beautiful, rosy, maybe sexy, about securing the future. Okay, all right, and with artificial intelligence, awesome. And there is no intelligence earlier in the security system, therefore they are bringing in artificial intelligence, right? Now, is it correct to claim such statements, right? That is what I would like to question few things. It's all about, many times the business world tries to find a balance between the technical value versus the value they market, right? And with that, there creeps in the notion of buzzwords and incorrect usage of terms, right? And that is a problem we have today, in not only with cybersecurity landscape, but also almost anywhere, right? Because people do not understand the challenges, or even if they understand, they do not want to talk about it. It's like dirty laundry, But everybody knows that. That's the tragedy of the commons, right? That artificial intelligence has several technical barriers, several technical walls, as well as several business walls, several legal and compliance challenges that we need to address before we claim that we are actually solving a problem fully with AI, or is it ML, or is it just data analytics, okay? Or is it a mix of all those things, right? So you look at, with that starting comment, which sets the tone, right? There are several companies which focus on predictive analytics and tries to do malware analysis, try to do threat hunting, access pattern isolation for intrusion. They want to do automated security, right? There are mobile security, identity management, etc., right? Deception security, all things are out there, right? But I'm not going to go into in one specific area, because that will cover the entire 1.5 hour given to me, or the total 2 hours even. But because there is there are companies, several companies based on that, so that you can imagine how much worth of information that is there to discuss, or knowledge that is there to discuss. And I may not have all the knowledge, to be honest, I'll say. So to be fair with you, and to be clear, to drive important foundational points, right? I'll be talking about the foundational challenges any AI company looking to solve cybersecurity problems using AI and ML would face, okay? And what are those challenges, how they could address them, okay? All right. Thanks, Rajiv. Next slide, please. So in this talk, I'll be starting with let's try to understand the three key aspects of security: intent, value, and assumption. Most often CISOs, security leadership, or security engineers, or entrepreneurs actually ignore these things, and they start diving in to solve a problem, right? And it's important to give a background of what we are trying to address. Let's try to understand the problem, analyze the problem, address the problem, and then come back and try to see how we can take care of these problems, right? Then we'll go into traditional versus data-driven versus intelligence-driven cybersecurity. We'll talk about assumptions and enablement, right? How we can, how assumptions are used to enable certain solutions in security. Challenges. We'll go over several types of challenges that will cover challenges with respect to data quality, biased AI, trusted AI, selecting an algorithm, challenges with respect to data isolation, like data islands, AI ethics and compliance, and at the end we'll also talk about your bias, right? When you since you are building a business, right, you have to sell, and who would be your buyers? Would be the CISOs or the security leaders, right? So since I have had those roles earlier, I can put forward some thoughts there, how what challenges CISOs face and what challenges you face in making this match work. Okay. So CISOs should be able to take care of their perspectives while evaluating AI startups for cybersecurity. All right. So that is how we'll progress. Next slide, please. Okay. Now I'm going to quote someone who we know. In fact, Rajiv also knows him very well, right? Gene Spafford, known as Spaff, right? He is one of the foremost cybersecurity experts in the world, and very highly regarded, very down to earth, but at the same time highly learned person, right? And he has done congressional testimonies in US and other places, and one of the quotes he has in 2005 is this, that data can get you to knowledge, right? But sometimes, not always. Data is not necessarily information, and information does not necessarily lead to knowledge, and knowledge is not always sufficient to discover truth and breed wisdom. Right? It's extremely important, right? Important for anything with respect to using data or harvesting knowledge out of data, and using data especially for cybersecurity, because discovering truth and breed wisdom is a bit philosophical to a certain extent, but there lies one important fact. Next slide, please, Rajiv. Is about to infer or discover intent of a party. So I took the liberty of extrapolating Spaff's comment here to infer or discover intent of a party. Now intent is important in security, right? I hope all of you know that, right? Intent means whether someone, a user, intends to remain as a user, as a legitimate user, or a legitimate developer or a provider of the service, or the user has the intent of an attacker, of being an attacker, or attacking the system, or compromising the system, right? So discovering the intent is extremely important in identifying whether the bug manifested as a bug or the bug was exploited as to be a vulnerability to attack the system. So many times the decision at the security review boards, often lies on that thin line. What was the intent of the attacker? Because the user did not intent of the user or the attacker, right? Because the user did not leave any trace that he or she compromised the system, okay, or he or she exfiltrated data, right? Or he or she is selling data in the dark web, okay, or the system has been compromised with malware, right? But or as part of a botnet network, it is active. So to many times you have to find out whether you can go after a party, and that requires to understand intent, right? So data often, as we use in AI or machine learning for training or other things, right, may not always provide the, and perhaps that will be in this talk. Next slide, please. Rajiv, next slide, please.
Hey, Ashish, I think you're breaking up for me at least. You able to hear us?
Okay. Yes, I can hear you. Is it better?
Go ahead.
Hello.
Yeah, it's coming in and out, but keep going.
Okay, sure. Thank you. So, so let me try to talk about like what do we protect and from whom, right? So if you look at a simple system here, right, a user and a target system, right? The user and target system will have essentially be talking to each other over a communication system, right? Initially started off as a keyboard and a wired system, right? So the user will type into the keyboard and see. But today it is kind of, you can talk to a system via Wi-Fi, via internet, essentially network connectivity, or via Bluetooth, NFC, or certain other mechanism, right? Especially with AI, this communication mechanism becomes very, very interesting, right? With adversarial inputs. Now there are at the user level, right? There are who is the user? Is it an external user or insider user, right? Or authorized? So there are different parameters associated with the user, right? And sometimes you like know who the user is. You want to identify the user, or you want to know more about the identity of the user, who this user is. Essentially, with the from the IAM perspective, or from the physical identity perspective, right, or virtual identity perspective. Right? Then there is another part is intent, right? Similarly, for a target system, there are several different metrics that are code, data, the infrastructure like network, hardware, OS. There could be authorized users, their information, right? You can inject bugs, or you can actually exploit bugs to make them into or known vulnerabilities, right? Into zero-day attacks or one-day attacks or even multi-stage attacks, right? And network and a network can be targeted, right? Now, what we need to know, why would a user attack a system, or why would an attacker have an intent to attack a system? What value that the system has to attack for, right? That is a key aspect that we need to also look at, right? Essentially, when you try to do risk assessment of a system, right, or the during incident response process, right? That time we like to identify why a given system was at higher risk than it was thought to be, right? So that is where comes the notion of what value this system could have for the attacker. So that is where comes that that thin line, right? Next slide, please, Rajiv. So can you guys are you able to hear me properly? If you are not
Yes.
hearing me, please also inform me or post it on chat also. Okay.
We can hear you.
So, okay, thank you. Yeah. So this is where, so if you look at essentially from an cybersecurity perspective, right? There are three parameters I'm going to we'll talk about in the context of AI/ML. Is the intent of the attacker or the user, the value that will be exploited for the system, and the underlying assumptions. What I've seen in my last 15 years of direct engagement in security, right? During my PhD as well as at IBM Research, at Neuro for self-driving cars, and several few other startups, right? Is that assumptions that are taken by systems or security systems are often not talked about. It is a problem not only at the side of who develops those systems and sells them, like the businesses and the startups, but also at the level of leadership, security leadership. And that is a bigger problem, So that and it's going to be a longer talk if we go in there. But assumptions are key aspects of security. What do you assume? When do you assume that the system is going to be under attack? What kind of features are going to be left as designed features? What kind of bugs are going to be left as bugs, not as vulnerabilities? How you build the security systems, thinking that you are going to ignore certain types of threats, right? So those assumptions play a major role. And I have not seen any, almost, I won't say any, that will be kind of presumptuous to talk about like that. But almost any of the startups today do not talk about assumptions. And people who have significant technical background, especially those who have co-founders or entrepreneurs, I'm sorry to typify that, or who have understood how crypto systems work, right? Crypto systems start off with assumptions, okay? And major security research papers talk about, or almost any security research papers talk about threat modeling, trust assumptions, etc. Right? However, in the world of practicing, these assumptions already go away. Even in the internal meetings between CISO and the teams, they don't keep up with the assumptions appropriately. Okay, so that's why it's out to you guys that when you go and try to develop your technologies and sell your technologies to CISOs, make sure that you bring out the assumptions you have taken while building the system and the assumptions that are needed to run and operate these systems. Okay, so there are three metrics here, key metrics we'll talk about: intent, value, and assumptions. Next slide, please, Rajesh. Next slide, please. Yeah. So we're going to talk about trend in cybersecurity technologies, right? You might be thinking that why I'm not diving down totally into AI for cyber directly, but I need to discuss this because cybersecurity has been there from the beginning. People have talked about cyber. Turing himself worked on cybersecurity in breaking the Enigma code, right? So therefore, Therefore, cybersecurity is not a new thing, but it is the application of upcoming technologies for enabling cybersecurity is a new trend. Therefore, I want to establish the key requirements that will remain invariant and that needs to be protected or that needs to be honored by the new technologies or upcoming technologies. That's why I'm bringing up why the next trends. Okay, thanks, Rajiv.
Okay, Ashish, some of the formatting might have gotten messed up because your PPT has been converted into Keynote format. So hopefully you'll be able to adjust with that.
Sure. Yeah. Sure. No, thank you. Till now it looks great, but thank you. I'll try to adjust in real time using some natural intelligence. so the existing technologies for traditional are still kind of the upsurge of AI and ML. Like let's say till 2000 or so, or data analytics was traditional. Like it was more formal verification, formal security models. Compositional security. You look at work from CMU, Stanford, Berkeley, or even other places, right? From IBM Research, Google was not there to get, etc. Right? So they primarily looked at formal methods of security, right? Formal verification of code. And most of these times, these security principles and techniques and systems were kind of deterministic, at a loose sense, right? Not to a formal, to a hard and fast sense, but to a loose sense, they were kind of deterministic and they are rule based, right? Okay, if this user comes in and this password matches, okay, allow that person, okay, kind of that. And one of the great examples of that is development of crypto, right? So crypto here is not referring to cryptocurrencies. There's a huge ambiguity that has been created recently. So, but it is about crypto systems. Okay. So the crypto. Okay, I hear some noise here. So the crypto systems are highly formal. They have a deterministic sense that they provide a notion of what is protected, what is not protected, what is the level of protection. Right? They have a notion of probability also there, but because the probability is based on hard problems, right? Mathematically hard problems. Therefore, we can ignore them and say that they are kind of deterministic, right? Next came towards in sometime in 2000s, right? Where data-driven cybersecurity technologies, right? They were kind of semi-formal because data came in, right? And data, it will be statistical in nature, right? Whenever statistics and probabilities come in, things become a bit fuzzy, and therefore they are not going to be supported by formal verification methods anymore, right? But the gap that traditional systems provided is that people are users or attackers, their intent was not clear, right? It's hard to model their intent. It is hard to model system values. It's hard to model assumptions, right? And it's hard to reason about the relationships between different components of a system, right? So therefore, we needed to understand what the real-time data says to be able to understand whether it was an attack or not, or what kind of attack it was, or what kind of code it was, right? Was it a malware, or was it did it have a signature of a malware, or was it a benign code segment, right? Whether the data contained any code injection attack kind of thing, okay? So, and then what happens is that from rule-based, the systems frameworks migrated to data and policy related and event based. They brought in events. If there is a specific event, right? If a given system is accessed by a user at night, and when it was not being accessed, right, then it was a problem. So such systems was kind of looked at CM, the event monitoring systems, right? One example is, let's say, QRadar, right? QRadar looked at network logs or sys logs and provide analytics on top of it, analyze that data, and provided that, okay, this kind of access requests are not good, so they could ward off, let's say, denial of service attacks or even intrusion, right? So, but they could not go into more fluid notion of attacks, right? Because attacks need not always be manifesting its footprint in the data. Right? So data, sometimes the logs may not contain what happens, what does the attacker is doing, right? So, and there are so much of logs that just analytics, statistical analytics cannot consume and process that amount of data. Right? So, for example, your Hadoop and Hive based systems, right? Then so MapReduce, then Spark, right? All those systems, they can process gigabytes and terabytes of data over several days, but the real-time nature of attacks and real-time nature of response to incidents, right, could not be enabled, right? And we could not also enable the prioritization for a CISO. So the CISOs would like to see a prioritized list of incidents, right? That what kind of incidents? What are the incidents today? Top 3 incidents today that we should look at, right? That's how CISOs look at. But that's not the prioritization is missing from that way to a good extent, because of the data is so vast, right? It's like finding a needle in a haystack. Then we go into, right, okay, why don't we enable systems to be intelligent in processing, consuming, and learning from the data by themselves, okay, and then help us understand what could be going on there, right? So that is where intelligence comes in, and that is where we are talking about AI based systems, right? However, AI based systems are at this point are primarily machine learning based systems, and some aspect of those machine learning based systems we are either calling as deep learning systems, right? We'll go into a brief background on some of them, right? But such systems are kind of more autonomous, if not fully autonomous. They are hard to formalize. They're hard to reason about, Perhaps that is why it's hard to formalize also. They are highly probabilistic, as in data-driven was also. They are learning-based, right? And they talk about features, data, and sometimes policy if the systems are kind of hybrid in nature, right? But and they primarily talk about features, right? And they are the first-class entities there. Now, ML-based systems for SIEM are there. IBM is developing that. Everybody, like you talk about Palo Alto Networks, or even FireEye will come and help you with that. ML-based DDoS, Cloudflare is there, right? That provides that kind of protection. ML-based malware detection, right? That is there almost everywhere. I don't remember the name of the company. For example, one of the first few companies started in this area was from UCSB in Santa Barbara. I think it was Vinia and others for us. But though it requires a lot of analysis of malware code and other things, and then they train a machine learning system to determine whether a given code segment is a malware-based system. But the challenges are also with APTs, right? Advanced persistent threats. or multi-stage attacks, right? It's very hard to determine whether a given malware code is malware code or not, right? So, but however, this is how the trend has been, and this is where we are today. Intelligence-driven systems for cybersecurity. They are hard to formalize. They are probabilistic in nature. They are learning-based feature and data policy, right? So, next slide, please. Rajiv, next slide, please. Yeah. So given that background, right, if we look at the intelligence-driven cybersecurity systems, right, there are kind of, at a high level, there are kind of three types of systems, right? One is a semi-autonomous security systems. Right. So, Rajiv will, yeah, there is there. So, thank you. So, semi-autonomous security systems. Those systems are essentially the ones that are not fully enabled with taking decisions or deciding whether a given access was an intrusion. Okay, they are governed by some other system policies that is encoded or governed by system admins. Okay, and so there is an overlap with human-assisted AI for security. So the human-assisted AI for security systems are where the AI assists human beings and human beings assist AI in terms of the following, right? They try to develop, the data is cleaned for the AI by human beings. AI sometimes cleans the data for the humans to look at them, okay? Human sometimes looks at the code and says that, okay, this specific statement seems to me to be part of a rootkit, okay, because the AI based system has not been trained for such rootkits, therefore it cannot recognize. So human assisted AI can help that, right? Sometimes AI based systems can determine that, hey, this looks to be a rootkit related statement. So the human based operator can try to find out what is going, how it can affect the system security, right? So that is the, maybe I should have called it a human centered AI, okay, but they are similar thing kind of, right? So and then the next part of the spectrum is autonomous security systems, right? The autonomous security systems are the ones who operate by themselves, right? Where it's not necessary to intervene for a prolonged period of time for the decisions that security systems make in terms of at the intrusion IPS IDS level or the firewall level or at the level of system level protection like OS and OS patching, etc. Right? So that is how the spectrum is. Yeah. Next slide, please. So yeah. So given that kind of landscape we are in, right? I would say that we should be currently either in the left side or middle, and that is where comes the supervised versus unsupervised, shallow versus deep learning kind of framework, right? We have not talked about much of reinforcement learning, but it will fall into somewhere here, right? So support vector machines, if you look at traditional machine learning, right? SVMs, logistic regressions, etc., they fall in the left top quadrant, right? They're shallow and supervised. You have level data, and so what could go in here, right? if you look at, let's say you are trying to do access pattern recognition, right? You want to identify whether a given access request is an intrusion or a high risk access request or a low risk access request, right? Perhaps there is a lot of data around that. You can get a lot of logs. All these systems are enabled for that. Syslogs, and you have the reverse proxies that are logging all these events. You have even the firewalls. They log this kind of requests also to some extent. Not firewall, sorry, at the network level, syslogs. My bad. So they have data about those events. Right? So you can apply all those data and perhaps carry out a supervised learning on identifying whether a given access is anomalous or not, right? But when you apply that kind of a access pattern, the challenge that they fall into a challenge. Okay, I'll come back to that later. There is a challenge for a startup that focuses on that. It is a low-hanging fruit, but from a business perspective, it might get tricky. Now, the other one is denoising encoders, like your autoencoders, right? Or sparse coding. They are unsupervised, but they are shallow. They don't have any deep learning neural network. Right? Now, if you go into deep learning neural networks, then you have CNNs, RNNs, graph NNs. You have LSTM-based systems. So, and those systems can identify features which are kind of latent in the data, and determine what is or help you in identifying and classifying, let's say, malicious versus non-malicious access request. Right? However, the question is deep learning, since deep learning is inefficient, requires a lot of resources, requires highly compute intensive. Therefore, it should be carefully chosen that if we can solve this problem using shallow machine learning or traditional machine learning versus should we use deep learning. Right? Many times the buzzword with the current industry is that is deep learning, right? And therefore, if you look at both in academic research and industry research and in business specific developments, right, or startups, right, across them, deep learning is a buzzword that everybody is taking. And at times I've had discussions with my other colleagues when I was at IBM Research. We used to discuss and try to see whether deep learning is necessary and can overcome or override all the other machine learning algorithms and systems. And the answer is no. Right? Deep learning can solve only certain type of problems. Okay, can help you learn on certain type of data, on certain types of feature vectors, while traditional machine learning can do better in many other data sets, right? So one needs to, as a startup, as a co-founder or an engineer, right, one should be able to determine whether they are going to deep learning or whether they are staying with traditional machine learning and why, right? Similarly, on the y-axis, whether they should go with supervised machine learning or unsupervised machine learning, right? Because, so I talked about shallow versus deep and what are the challenges there, right? Or essentially what the key metrics there. Shallow may not ask you for too much of compute intensive power, but may not be as accurate in some type of data sets, but could be accurate in many data sets, right? But for deep learning, it could work on when the data is essentially, I'll call, when the data is kind of have is a complex data set, right? Like images or videos, right? In that context, the deep neural networks, right, could help determine the features that are there in the data. So, but in terms of, if you go to the y-axis, supervised versus unsupervised, right? In supervised machine learning, you need to have the ground truth and the data sets, in a clean and unbiased format, right? So that is a requirement, right? But you have a lot of control on how your system is going to behave. In case of unsupervised machine learning, right, you don't have much control on what the system is going to learn. It might, depending on the mathematics, underlying mathematics of the machine learning algorithms, right, it might learn something else than what you want it to learn, right? So,
Ashish?
yes.
Ashish, can you hear?
Yes, Rajiv. Yeah. Yes, I can hear you.
Okay. Just a very quick time check. It's almost 10 o'clock. Can we take a pause here to see? I think you have given a lot of technical, in-depth, a lot of great points. Can we take a pause to see if people have any questions on this? Because I think these are critical points: supervised, unsupervised, deep learning, shallow learning, the various strategies. Are there any questions?
One shot, inhale. Shut. Exhale. Step the right foot, drop the back heel, inhale, reach up. Hands together, look up. Ashto, exhale.
Sorry, I cannot hear clearly what is being spoken.
Dasha, exhale. Ekadasha, left foot steps, right heel drops, inhale, reach up.
Who wants to ask?
Rajiv, sorry to interrupt the speaker. Rajiv, I cannot hear.
Yeah, same here.
The question properly.
I don't know if that is a question or if that is background noise from somebody who is unmuted. Okay, so I think there might be some audio issues as well. So people, if you have any questions, do post it on the chat, and Abbas will. Abbas, please, if there are any questions, then just pause us and ask those questions. For now, let's go ahead, Ashish. Let's continue. I think you have quite a bit of material talking about the applications, business applications, CISO stuff, practical scenarios. So let's go ahead, and Abbas, please continue to mute everybody except Ashish and myself. Thank you. Go ahead, Ashish.
Thank you. Yeah, thank you so much, Rajiv. And please, my request is please post your questions in between, and we can talk, take it forward. Yeah. So to summarize this slide, right? This itself has a lot of material here, but the point is that in cybersecurity, when you decide on using AI and ML, right, you need to make a decision which quadrant you are going to play. Just to start with from a top level view, right? You started with the root. It's kind of a tree, right? You started with a root called AI ML, right? Then and cybersecurity. Then you say, okay, which quadrant you want to go into? You want to go into the left topmost quadrant, shallow and supervised learning. Or the right top quadrant called supervised and deep learning, right? So that determines your specific cybersecurity use cases you are solving. You should have deep insights into the algorithms why you are using. Before that, you should understand the data, right? What I have seen is that people don't understand their data, and they try to say, hey, I'm going to now apply this algorithm. That's why it is machine learning is so data oriented. Like you should try to understand your data, play with your data first. Try and also try to look at why certain type of data can be good for support vector machines and not that not that much appropriate for CNNs. Okay, so that kind of understanding of the mathematical principles behind these algorithms is important. Okay, the challenge that we have in today's ecosystem is that we see a lot of engineers. So as entrepreneurs, when you hire engineers, right, in your company, that many of these engineers do not have that deep background on mathematics, statistics, and machine learning and deep learning together, right? They are just AI applicators, right? They learn AI from these different courses out there. That's good. I appreciate that they are doing that. But my point is that doesn't give them the necessary mathematical and foundational background. And that, in that sense, you need to have other team members who can help decide based on mathematical principles and based on the algorithmic principles of AI, why you should go for supervised versus shallow, or which quadrant you should play in. Okay, so that is extremely important, because once you start off in developing a system in a given quadrant and you are going all course, you have put all your money in it, right? If you have any money to spare, okay, as startup founders, I can tell you that, like every change is an important paisa or penny, right? So if you're going to all fall for, and then at the end, oh dude, this was not the right model and we are not able to improve our performance, our accuracy. But if you would have used the other types of algorithms, then we would have been successful, right? By that time, the customer would have gone, right? So you would have lost the opportunity. So it is a very fine balance between chasing after the opportunity versus spending time to understand the problem, understand the data, understand the algorithms, and deciding on how to implement it and evaluate it. Okay, this I hope this talk is helping you in doing that. Okay, next slide, please. Sorry, I spent a lot of time in this previous slide, but I could have had more slides there, but I didn't want to just have slides, but essentially talk and sure the important points are brought out. So this next set of slides will actually bring out few aspects, right? This slide talks about what does the AI/ML for cyber provide as an opportunity, right? Because as you see the trend, right? The trend has been from traditional to data-driven to intelligence-driven cybersecurity technologies. That trend is going to continue, right? We cannot prevent that, and because that is a trend of evolution, right? Everything is getting more and more intelligent, so therefore we need to protect with intelligent systems, right? Attackers are using AI for attacking, therefore you need to also have AI for protection, right? So and we have seen that there are hundreds of billions of dollars worth of breaches every year today, right? That is because we cannot blame entirely traditional data-driven approaches, but a fair share of those blames should lie upon traditional data-driven approaches, right? And another share should lie upon the incompetency of the security leadership as well as the business leadership. Okay, and also not to say security engineers. Okay, so the humans essentially there's so much of data today, right? As the trend continues, right? there are terabytes of logs per day in a given cloud platform, right? If you and how do you handle such level of data? And you want to gain information out of data. You want to gain knowledge out of information. Remember the quote from SPAF in the beginning I mentioned, right? You want to harvest from the data, right? How do you harvest so much of data every day? Right? It's impossible, almost impossible. Maybe you can learn from it, right? So that is where you want to bring in AI ML to learn from the data, right? Now it also is important to look at a notion called integrated cover, that you look at multiple components, multiple data sources, and try to correlate those data items, right? And see how AI and ML can help in correlating these data items and providing an integrated view of what is going on in your system at the network level, at the system level, or at the data level, or the user level, or the application level, whatever, and you can provide that kind of insights by using AI and ML, right? That opportunity is there. AI and ML can help extract latent features, right? Remember, the data-driven analytics is primarily statistical analytics, right? But learning latent features is something needs to be done, and AI ML can do that really efficiently. And AI ML is faster because of today's advancement that is ongoing. It is not fast enough, but it is faster. So we should be able to use AI ML as we go for, right, for cybersecurity. Next slide, please. Rajiv, next slide, please. However, sorry, yeah, I think there's a lag. Yeah, I'm sorry. Yeah. So given those opportunities, right? How do you enable those opportunities, or how do you take advantage of those opportunities and enable AI/ML based cyber systems, right? But there are challenges. Otherwise, any why would they be? They already there. People would have already. If you have billions of dollars of market share already stacked there, right? There will not be any opportunity for startups. These challenges are the ones are there for startups to solve, because startups are agile, flexible, and can move faster. Unlike big businesses, sometimes they can move, they can be flexible, but not move as fast as startups. Right? So therefore, these are the challenges that I should bring it up to you guys so that you can solve them. Quality of data, and these challenges are across the spectrum. Everybody would feel faces these challenges, right? Data related challenges. One key aspect is data quality. Many times, so when I have looked at data from different types of systems, cloud, mobile and IoT based systems, applications hosted on cloud, AI based systems, you have robots or autonomous cars or other things, right? Those systems, right, often will be therefore they don't have the right data, right logs that are collected, right? So if you take your business, take your technology to a startup that does not log things appropriately, your system is not going to provide the kind of value that they thought of, right? So you will not be able to retain the customer, right? But before that, how would you train your system? How would you ensure and validate your system is working fine, right? You need high quality data sets, right? The ground truth should be good if you are using supervised or semi-supervised machine learning, right? So for that, you need to work on the data. You have to collect the data, work on the data, clean it, find missing parameters, fill them up, drop rows or or ask the data owner to provide you more data. It's the whole data curation paradigm is an important aspect for AI in general. But for cybersecurity, the quality of data is important because you just have only logs, right? Or maybe you have software code to some extent, right? What else you have? You have CVEs, right? But CVEs are kind of input as data, but they are kind of I would say static data, right? You have only 100 or few thousand additions per day, right? So if you look at the data landscape, right, it is the logs, but logs cannot identify intent or model intent, cannot model assumptions, or cannot model value of the system clearly. Even if they can model assumptions and model values to some extent, they cannot model intent properly. Okay. In fact, there is a study by the U.S. government, and that clearly mentions that modeling attacker intent is an important problem in AI for cyber. Then you have data, but the data is encrypted. Imagine that you are a startup for doing IPS IDS over using deep packet inspection, right? Now, to carry out deep packet inspection, you need to have access to the payload, right? And the payload is encrypted over TLS. So, how would you deep packet inspect? There are some startups again, they kind of are thinking of doing that, but the ideal answer here is homomorphic encryption. Okay. But homomorphic encryption, as if you might be knowing, are not as practical as you would like to be today. It might be there, but there will be IP issues, etc. Right? In this talk I have not covered IP related issues, right? Because even if there are technologies you can use for solving these AI based challenges or AI related challenges for cybersecurity, there could be IP issues. You should be careful in how you solve them or how you use them. Right? Now, the next type of problem is data islands. Right? You look at GDPR. I'll come to GDPR later, but when you have private data, right, for example, healthcare data, nobody would like to share the healthcare data, especially in US, right? They will never share the healthcare data or access logs, for example, of patients to a security startup, because first of all, you are a startup, the trust has not been established. Second of all, the data is private, the data is regulated, right? So there are data islands. You cannot have access to the data. It's kind of the dark web of the data, right? Deep web of the data. Deep web of the data, right? Where you don't have access to that. Then the other problem is poison data. So many times you will say, hey, I have got access to this data set. It was open source. It was available in GitHub or available from this other website. I'm going to use it and train my model for doing intrusion detection or for malware analysis. What has happened is that maybe the data has been poisoned and has been put in there for you as a bait or as a way to build a vulnerable system, right? So data poisoning attacks are quite common, and in cybersecurity startups, this becomes a double-edged sword, right? For cybersecurity startups using AI, right? First of all, you are using AI to protect another system, right? However, you should know that trust of your system is also kind of a fuzzy one. People who are careful about knowing about what kind of data you have used for training the system, they may not trust your system. They will say, tell me about whether your data was poisoned or not, right? So next slide, please. So therefore, ensuring that you have the data set that is trusted is extremely important. Rajiv,
Hi, can
we
you hear me?
see the screen? Yes, we can hear you. We cannot see the screen, the slides.
Okay, 1 second.
So,
something. Give me 1 second. Can you see it now?
No.
We still don't see you as the presenter, Rajiv.
Oh. Can you see it now?
No, it's a blank screen.
Okay, so we are seeing you as presenter now, but it's a blank screen.
Okay. I think Zoho has some problem just sharing one application. Let me, I don't know what happened at the moment. Abbas, can you, it says waiting for host approval. Okay, see now?
Yeah, we can see your screen now.
Oh.
Okay, next slide, please, Rajiv. Yeah.
Wow, there's a
Thank you.
really loud, loud rooster somewhere.
Rooster, yes. 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 So, by the way, I saw a message popping up that the meeting owner or the host has to rejoin or start the meeting again after maybe 15 minutes. That is at 10:30 a.m. IST, and that otherwise everybody will be kicked out from the meeting.
No, I think that's now
Maybe they have
disappeared.
90 minutes.
It's not disappeared, Ashish.
I see.
think we should be good.
Okay, thank you. Thanks.
And I'm not sure if the audio
going
is okay
forward,
for everybody. Making up for me.
so can you hear me, everyone? All right. I will assume that everyone can hear me unless there is a next
Waking up for me, but
yeah.
go ahead, keep going ahead unless somebody complains.
Okay, thank you. So, so the challenges from data. Let's move on to intent, right? The biggest challenge, as we talked in the beginning, right, is about identifying intent of a user, whether it is the intent is to attack a system or to use the system, okay, or no, so, and then going into another level, what is the intent of the attacker, right? Is the attacker trying to compromise the system, or to use it as part of a botnet, or to access some data, or to exfiltrate data, like that, right? Now, the problem comes here is that the modeling user intent is not that easy, right? It is a hard problem. How do you intend? It's like we human beings have been trying to model intent of another human being from the like and there is psychological there are a lot of psychological studies around that, right? So in our case, the attacker intent is part of cyber psychological studies. There are a lot of studies who try to say why does an attacker intend to attack, what motivates this person. Therefore it is hard to quantify, hard to model, and hard to learn also. So therefore, a given whenever you are building a cybersecurity system, you should identify the role of attacker intent or user intent there. What is the role it plays in your system, right? Similarly, intent of a code segment, right? I have not mentioned it here, but whether a given statement in a program is benign or is meaningless or is meaningful, and if does the meaning relate to an attack? Okay, so that intent has to be identified if by any machine learning system or any system that tries to analyze code and identify malware in a code, right? So, and the next part of intent is to identify the attacker goal. What is the goal of the attacker that is trying to achieve? Is the goal of the attacker? So there are different goals of the attack, a given attack, right? And this should not be, it need not be part of your system, but it should be part of your understanding the problem and why you are building this system and how you are helping your customers prevent the attacker achieve their goal, right? Essentially, when you say protecting a system, means you are protecting the system so that the attacker cannot achieve the goal. You know, it's hard to prevent attacks, right? So attacks will happen, but you are successfully thwarting an attack by making sure that the attacker is stopped in somewhere before it reaches the goal. The goals could be as I said, like compromise the system or even state sponsorship of attacks or terrorism or mining bitcoins, etc. Right? So this is a big challenge as I see, and that would affect using autonomous security systems in an independent manner, right? Even if we use autonomous security systems, we will be needing some human assistance or some other sort of assistance from maybe different type of trusted agencies or trusted systems for making sure that the autonomous system is identifying intent carefully and attacker goal carefully there. Okay, so next slide please. So and similarly, right, we talked about intent. The next type is talking about value of the system. Why would an attacker attack a system, right? When you do threat hunting, right? When you do threat hunting or when you do risk assessment of a system, you need to determine whether a given system has enough value for a given type of attacker. So you are assuming, I will come to assumptions later, but we have talked about assumptions earlier as well. So you are making assumptions about certain types of threats that your startup is going to address this kind of threats, okay, for this kind of domain. Now, given this assumption, you want to determine whether such type of threats are interested to find a given system valuable or not, right? So modeling the value of a system is important for risk assessment. You know, it is ignored in many places. So and that is these are all research questions, open-ended research questions. You also need to look at value degradation of a system after attack. Right? So how does the value degrade for a system, right? And is it does it degrade or essentially, I should say, after detection or identification that there has been an attack or there has been an incident, right? It is during incident response phase, right? You need to identify whether a given system has degraded in its value or not. Right? Now, that is where comes legal and financial liability, right? That if you are a startup, you went in and to say client X saying that I'm going to protect your system and therefore there will not be any data exfiltration attacks, right? But there are certain other attacks that were taken that were carried out on this system. Are you immune from the legal and financial liabilities because of that attack? Right? Your customer might file lawsuits saying that you claimed certain things but it did not work out. How will you ensure that value degradation and liabilities legally and financially? Right? So that is where you want to also carry out value modeling, and these are hard problems to do that. So what I'm trying to say is that when AI-based startups claim certain things, because they're non-deterministic in nature to some extent, their protection is probabilistic in nature, hard to quantify in terms of formalization, right? You are prone to being held accountable when you are not accountable. Okay, but you are also prone to make mistakes in identifying intent, value, and assumptions. Next slide, please. Similarly, assumptions, right? So here I'll focus on assumptions about type of threats you want to protect, right? You will make that kind of assumptions. You will make kind of assumptions about data availability or data quality. Okay. You will also make assumptions about time-sensitive nature of your inference. Right? If there are terabytes of data that you have to process, and then give a almost near real-time prediction or identifying an attack or an incident, right? You have to be very careful if your machine learning system can do that, right? And also you have to be careful in whether your machine learning system is being deployed or operated by the customer or being operated by you, right? Maybe the customer might be running it on a low power GPU, therefore the time sensitiveness is gone from there. So you have to look at those assumptions, right? And the assumptions about AI ML algorithms, right? You want to know what the mathematical principles by them. If you want to say, hey, logistic regression works this kind of data, it's going to work for my security data sets. Not always. It may not work that way, right? Because the features you are looking for in security data sets are kind of totally different or very different set of features than the other applications of such data. Next slide, please. I'm going to a bit hurry up now, given I'm nearing almost 1.5 hours, so that I can leave time for others for questions. So a few slides, but I'm going to quickly touch upon key points and move on. Now, the other aspect of AI for cyber is trusted AI. Right? See, the key aspect is you have to make sure your AI is trusted by your customers, so that you can protect or provide trust and protection for your customer. And this is a double-edged sword. You are basically have to guarantee two types of trust, or trust for two systems, or protection for two systems, right? However, many players in cybersecurity industry, right, do not think about that. Especially startups, they build security systems, but they do not ensure that their systems are also protected in a way, especially AI-based systems from data poisoning attacks. right? So that they have trusted data, right? Unbiased AI, right? So that they are not biased, right? So bias in data can actually be extremely dangerous for such startups, because anytime you say that, hey, this IP address seems to be the origin of the attack, and this IP address comes from China, right? You are opening yourself to a deluge of other attacks if that is a false statement, because that could be because of a bias in your data or certain errors in your data. Right? Bias could be that because you have your machine learning system has seen a lot of data points that point to attacks from China, right? It will be biased towards predicting or inferring that it also belongs to China, right? Now, if it doesn't belong to China, still you say, because it could be that the attacker is using systems like the network privacy systems, okay? Like using Tor or other kind of such systems, right? So there could be the source of IP address may not be what you are seeing, right? So therefore you have to be careful in there. So data bias can actually ruin companies there, which is people don't understand that much. And then how do you trust data, right? How do you trust input data in production, especially in real-time learning? Many times cybersecurity companies look for real-time learning, right? They learn because these are all streaming data. The access patterns are coming in every minute. Therefore, you will also learn from that as well, right? By doing so, you are actually opening up yourself from being gamed by attackers by themselves. Okay. Next slide, please. The other two aspects are compliance and privacy, right? I talked about data islands, like GDPR, for example, is doing a great favor for its European citizens, but GDPR is also creating a notion called data islands, right? And that is why there are already several reports on why it is affecting carrying out cybersecurity analysis. So, for example, a given website is hosting malware, right? But you want to know who is the owner of this website, and then take an action against them, right? But because of GDPR, that information will not be shared with anybody else, right? The privacy guard is in place by default. And access to such data is not easy right away. You can get that data, right? So therefore, if you are building if a startup is building such a system to determine malware based websites and protecting you from protecting your browser or your browsing habits from such websites, right? You may not be remaining protected for long. Because they cannot be shut down. So the other one is the other example, as I mentioned, right? If you want to identify access patterns and learn from it by looking at your IAM systems, right? You are actually getting access to privacy related answers, problems. So access pattern is a highly private set of data items. So when your system learns about it, it might be violating regulatory compliance requirements. And you should be careful in reusing or applying this system for another customer or somebody who is not authorized to have access to those patterns, right? It should also ensure that your data that is used by your system for training and testing or inference are supportive of healthcare and finance regulatory requirements or similar other regulatory requirements like CCPA, okay, or FedRAMP, or in India, Indian privacy and compliance laws, right? Which are not as developed and as enforcing today, but but it could be something later. Next slide, please. The other, we have talked about AI ethics a bit, but AI ethics are not properly codified today. But it could be racially oriented, biased, or unethical, right? So many times you want to say that, people say, hey, the cyber attacks primarily come from few countries in the world. So you are becoming racially oriented or biased, and that could lead to unethical behavior of your AI-based system. Right? It could also be used against your company, that you are not unethical, therefore you will not be able to sell your products to certain other companies. Right? And ethics in assuring ethics into AI or integration.
Hey, Ashish, we are not able to hear you.
Hey, Ashish, looks like we lost your audio.
Hello?
Yeah.
Hello?
Back.
Yeah. Sorry. Yeah. So after 90 minutes, actually, Geo dropped off my call, but so I'm back again.
Okay, no problem. Go ahead.
Now, so the last point is about CISO challenges, right? You are going to talk to CISOs when you try to sell your cybersecurity startups, cybersecurity businesses, right? That the CISOs today have have to the right perspective, or from their viewpoint, right? As I see, when I decide to buy or partner with a company and buy their product, or subscribe to their products, I need to ensure, first of all, how have they trained their system, right? What kind of data they have used for training? What is their ground truth? What kind of algorithm they have used? Okay, and then try to validate the system first, right? So those are kind of sometimes are uncomfortable questions for AI for cyber startups, right? Because they may not be ready to provide details of the data they have used for training, right? They may not be able to provide go for further validation because maybe the system is a prototype, So and how do you play accuracy, right? See, accuracy for AI has to be better than a human level accuracy. Then only it flies, right? So you need to make sure that the accuracy is a consistent one, right? Those are the aspects from CISOs, right? I'll also look at what are the risk of errors, right? So if there are errors, type 1, type 2 errors by your systems, right? Then what risk they pose for my my systems that it is trying to protect, right? Now, the other question is, I need to also think from my side whether I should use AI-based cyber or whether I should use traditional cyber, And many times it's kind of we'll go for, okay, I like to go for this kind of medicine or that kind of medicine. So we like to go for the one that we trust more. So people will like to go for trusted cyber, and they like to go for trusted players more than just startups and also AI-based cyber, right? So there is a bias in some of the CISO's minds, right, or security leadership mind, and that is valid to be there. And from the angle of startups, the CISOs sometimes are not equipped or have not upgraded their knowledge base to understand how to evaluate a AI-based cyber system, right? To understand their algorithms, to understand why this AI-based cyber system is better than the other AI-based cyber system or traditional systems, right? So the CISOs have to upgrade their knowledge and skill levels to do that, or especially have team members who are very good at that, right? Then only they can make informed decisions, right? However, I would like the leaders to remain as technical as possible. That is what I have a complaint against the security leadership in the industry, that as they go up in the chain, right? Many times they remain just they make business decisions or decisions, but they don't remain as technical as they require. In security, you need to be as technical as you can be always. Okay. And then so that will help them to decide when to employ AI-based cyber systems and when not to employ AI-based cyber systems, right? They'll also be able to validate the systems better. All right. So maybe there is one more slide for us. Yeah, we talked about that to some extent, but the point I like to make it here is that is the CISO equipped or ready for AI for cyber? They sometimes go for buzzwords, and they need to do the reality check. CISOs are hard pressed for time, hard pressed with the evolving challenges in evolving technologies, right? They have to always learn and be at the forefront in their learning and understanding how they can be vulnerable. But the leadership may not have the appropriate background, as I might say, and there has to be a decision about how much to pay, right? How much to pay? What is a buyer-seller agreement there, right? The other key point is accountability for AI-based cyber. I mentioned that legal and financial accountability and liability for AI-based cyber, right? If you don't play well, then the CISO might become, if the CISO is not aware of that, then it may not be able to determine whether the AI-based cybersecurity company should be held accountable or somebody else should be held accountable for a given risk. Okay. So this is where you should keep that in mind when you try to find your partners and players or customers. Okay, next slide, please. Now, so the conclusions is that we talked about AI for cyber. We got into some background. We understood that is a great opportunity. There are several technical challenges related to data, algorithms, verification of AI-based cyber, AI ethics. There are business challenges, with respect to availability of data, with respect to whether a business can evaluate your systems and then make right decisions. There are legal challenges that you need to look at, both from any data breach that happens or any attack that happens or any risk that you ignore, and there are also IP-based legal challenges. Ethics for startups is important for riding over buzzwords or ensuring that you are describing your assumptions clearly to people, okay, to your customers, and whether you are able to determine attacker intent, value of the system, and articulate the assumptions clearly, right? And so the CISO has to evaluate the square versus the circle, right? Which one it will fit their requirements, and whether it is square versus it is circle, that they have to be equipped enough technically and business wise to enforce. So those are the few points we covered. We'd like to open up now for questions. Thank you for your time.
Thanks, Ashish. So let's maybe go around and see if there are any questions on the various aspects of AI/ML. How about we do this? Can we, I'm sure all the startups attending here are using some aspects of machine learning or AI, right? Mostly machine learning, I would guess, in their products. Can we go around and sort of just mention how how your startup products are using machine learning? Any volunteers?
Rajiv, can I tell them to speak for a minute or two, like each and every startup, or I don't know how to?
Yeah, so sorry, Abbas, my audio on my end is not very clear. Yeah,
Okay.
what is it?
Do you want them to post in chat window so that I enable their audio,
Yes.
or do you want me to give transfer on?
No, let's go with the questions first. Yeah, good point. I just saw the chat, so let's go with
Riaz.
let's go with the questions. Yeah.
Riaz from Isabella will just enable it. Riaz, I think you can speak now.
Okay, yeah, thank you, Abbas. Thank you, Rajiv. Hey, Ashish. So the question here, right? Most of the inventions in the market, if you look at the AI or ML inventions, it looks, they have a good solution for data analytics or some passive analysis, right? But I haven't seen much inventions about, leveraging any algorithm for detection or prevention controls, right? So I just would like to know, like from your experience, do you aware of any algorithm or a product which is in the market, they are defining some maturity models for protections or prevention controls, right? Even SIM or even the Palo Alto or the FireEye, what you mentioned, right? They're pretty expensive. Also, the model what they define, it's only for analytics purpose, right? They may be dealing with the huge volume of data and coming up with some kind of like analytics. But again, when it comes to the prevention, they do much, So I just would like to know in terms of protection or prevention controls, leveraging this AI.
Okay. Thanks, Raj. This is an excellent point, and that most of the AI inventions are good for data analytics and or passive analysis, right? I agree with that, and but they use the buzzword for using AI and ML, right? And that is misleading for the security industry and the CISOs and leadership, as well as other people, right? However, there are some players who actually have developed technologies that use true AI and ML for detection and prevention controls. I won't say prevention, because prevention is a hard term to use in the context of for security. Okay, I would say detection, monitoring, and mitigation in a way. So for detection, there are so as far as I know, right, I have been party to. So at IBM security division, they have developed capabilities into, let's say, user behavior analytics, okay, UBA, okay, or also cloud security specific analytics, or that I am aware of using machine learning to a great extent. Network security has seen use of machine learning to some extent, because of the data is prevalent to be used and there are logs everywhere, etc. Right now, there are maturity models, but the maturity models are not pretty well defined, with respect to AI and ML based detection. So there could be, I might be missing them out. So if you know, please let me know. Does that answer your question to some extent, Reyes?
Yeah, definitely, Ashish. What I conclude here, I don't see any eyesight to see the prevention or the mitigation model, right? So even my startup, we are focusing on that to come up with some kind of like intelligence which can do the prevention based on the detection logics, right? So we do enable some of the detection logics here, but still we are ideating for the protection or the as you said, we don't want to say prevention, but more of a mitigation side, right? Yeah, definitely. We will let you know like if we can come across some solution around that. Yeah. Thanks, Ashish.
Aditya, I have
Okay,
enabled
thank
you.
you. Sorry. Yes, go ahead, please.
Aditya from Secura has a question.
Yes. Hi, Aditya.
Hey, I'm on the
So yeah, I
backline,
see
so
the question here.
please.
Aditya, you can go ahead and
So let's
on.
Okay.
Go ahead.
I want to know, have you heard of use cases on site or essentially security automation response? We have a platform and we are looking for use cases, but as you understand, we're getting alert. There's a lot of data, right? So figuring out the right use cases is like a challenge. Although I've seen a lot of things, mentioned ML based in their access when it comes to those use cases can't be right.
Yeah.
So just
So
seeing on it.
right. So Aditya, there are some noise. I cannot hear you fully, but as I understood and as I read from the chat messages here, that you want to understand maybe a couple of questions. One is about which quadrant do you suggest a source should play? To answer that first question, right? That the quadrant that you should play is again, dependent on many factors, right? Dependent on what are you trying to protect against, right? We cannot have a sore flow for any industry or any application, right? Or every application. We have to have it has to be domain centric or application centric or system centric to some extent, right? So or threat centric, right? So therefore, the sore play should be dependent on what is the target system you are protecting. The second one is data. What kind of data that you have access to for training your machine learning model, right? If you are doing unsupervised machine learning, do you understand the data that is there that will be given as an input to your system, right? And what kind of algorithms you want to use. So the important point is developing the unsupervised machine learning algorithm, the mathematical principles behind that. And therefore it differs from system to system, right? But primarily, if we look at the in security, we like to go for either on semi-supervised, supervised or semi-supervised, or human-centric or human-assisted AI for cybersecurity, right, as I mentioned earlier. So therefore, that would play maybe top half of the quadrant. That is kind of supervised or somewhere in the middle there. Unsupervised, one has to be careful there, right? Even in malware analysis, right, or malware detection. As you do vulnerability management measurement, or you carry out patching, right? You have to identify if there is a malware or not, or there is a vulnerability. That is where determining, using unsupervised machine learning, somebody can say could be useful, but is a bit dangerous because your machine learning algorithm might have bias embedded in it, and that can the inference cannot be fully trusted. Okay, I hope that answered your question, Aditya. Okay, I cannot hear you. properly. Can everyone hear me, or is it my problem, or can everyone hear Aditya?
Ashish, I can hear you. I think maybe Aditya's, there might be some audio problems on his end.
Okay.
But
Thanks,
let's
Rajiv.
go ahead. I think,
yeah.
So
The second question.
Go ahead with the second.
The second question that Aditya has is about what ML use cases exist for response also. So the response domain is kind of technical, but also have business and legal and regulatory requirements, right? If you know, especially the incident response methodologies clearly, right, then you have to play in those areas. So you have to develop machine learning to systems to do that. Primarily, that would be, you don't need you cannot do unsupervised machine learning here. That's for sure. Okay, you have to or that will be a rule of thumb unless there are exceptions. This will be primarily human assisted machine learning here for short responses, right? And what can for human assisted AI, the use cases could be about, so when there is a data breach, right? How do you respond to a data breach? Or if there is a DDoS attack, you can respond to it by immediately trying to divert the traffic, for example, or drop the packets, or carrying out a defensive attack. If you can identify origin of attacks, but that is hard to do it in DDoS level, right? So in that sense, yes, ML can be used in an automated response, right? But again, automated response can bring down systems or IP addresses that are able to withstand the attack, but you will just bring them down thinking that it will be attacked, right? And that could actually affect the availability aspect of CIA principles like confidentiality, integrity, and availability for security, right? So it is use case basis, and as I said, right, unsupervised machine learning, one has to be very careful in using for security, but semi-supervised algorithms could be useful. Now, for DDoS attacks, initial assessment could be, hey, can I use logistical regression, okay, and then determine whether there is a lot of load being generated, lot of connections that are remaining open-ended, is there a SYN attack, or what kind of attacks are there, like is there an amplification attack, etc., right? So you have to play according to specific type of scenarios, right? In that case also, protecting from all types of DDoS attacks or use cases is hard, right? Because then your system has been trained and could actually, as you know, right? If you have played with ML systems a lot, I guess, I hope you've done that earlier, right? Developing a multi-class model is much harder than developing a single class model sometimes, and then that would multi-class models will have more type 2 errors or type 1 errors. So does it answer your question, Aditya?
Yeah, I think he's just sent a message on chat saying thanks. He gets it.
Yeah.
And Ashish, just to add to that, I think it's also super critical in general for cyber. when deciding the quadrant, but especially for products such as SOAR categories, right, where you have an automated response. So the tolerance for mistakes because of unsupervised machine learning, right? The tolerance is really zero because you don't want to block ports or divert traffic or categorize a process as a malicious executable. You don't want to do any machine learning algorithm has deducted it based on whatever. So the human, I guess, becomes more critical in the loop for automated response-based products. Yeah, you agree?
Absolutely, I completely agree with that, Rajiv. Great point. So thank you for adding that. Is that it's like identifying whether a process is malicious or not is very important. And if a benign process is identified as malicious, that could actually result in times hundreds of thousands of dollars loss, or if not millions of dollars loss, because by killing that process, okay, one could actually be resulting in shutting down an entire system dependent on that process, right, and or making other systems leaving them insecure, right? And if that happens, for example, on a Thanksgiving time frame on an Amazon server, critical for orders from customers, right? You can imagine you are losing out on hundreds of millions of dollars.
Correct. So, and it is, I mean, it's not just a hypothetical example. It has happened before where some of the popular antivirus scanners have classified, Windows system DLL as malicious, and it has brought down entire enterprises. So, yeah, so false positive, I think the tolerance for false positives and automated responses for SOAR and so detection, I guess for all the detection categories of products, it's probably okay because you can still deal with false positives. You can have further pruning, filtering. You can have other operators later.
Yeah, I agree.
Filtering that. Great point. Thanks, Ashish. Any other questions? Okay. All right. I think we started a bit late, but looks like we are on time to finish the presentation if there are no more questions. So let's all please thank the speaker for a fantastic overview of AI ML applications to cybersecurity, both technical and business. And I mean, I've known Ashish for about, I guess, close to 20 years now. So he's been working in these areas at the top places, IBM Research, Purdue University, IBM Research, and after that, several startups. And now he's a co-founder of Cyfense as well. So he has a lot to share. So if anyone on this call later on, has other specific questions that they would like to talk to Ashish. Ashish, is it okay if they email you? I think it's there on your presentation, your email ID. Can they get in touch with you?
Yes, definitely. Thank you so much, Rajiv, for hosting me, giving the opportunity and the privilege. And I'm actually I know Rajiv, as he mentioned, for a long time, and he has been kind of a friend and mentor also. So he is an amazing person to learn from. So, and please feel free to send your emails, questions, or if you want to talk to me at some point. Okay, my email address is akundu@cyfense. So Cyfense, I'll prefer to keep that away, but my email address is akundu@sem.org, and we can use that to interact.
Fantastic. All right. Thank you again for joining today, and hope to see you back in a few weeks. Thanks, Ashish. Thanks, everyone.
Yeah. Thank you so much. Thanks, Karthik and Abbas as well. Thank you. Bye.
Bye-bye.